Welcome to my channel. Today I will share some helpful tricks to make memorizing derivatives of trigonometric functions and derivatives of inverse trigonometric functions. Let's start with the derivatives of trigonometric functions. We have 6 functions, that is sine theta, cos theta, tan theta, cot theta, secant theta and cosecant theta. Before start the derivatives, you need to remember derivative of sine theta is cos theta, derivative of cos theta is minus sine theta. The rest of the trigonometric functions are tan theta, cot theta, secant theta, cosecant theta. So we need to find 4 functions. For that, you have to remember one mnemonic, that is PSST. Here, P stands for positive, S stands for secant, another S stands for secant, and T stands for tan. These 3 functions you take it as in first row and then just write their co-functions as in the second row. That is secant cofunction is cosecant, and here also cosecant. Here tan cofunction is cot. Next, assign a negative sign on the middle of the cosecant. So this is the middle of the cosecant. You have to just assign a negative sign. And finally, add arrows pointing towards the middle. See, this arrow is pointing towards this middle, and here also add arrow pointing towards the middle. Here also add arrow pointing towards the middle, and here also add arrow pointing towards the middle. That means if you start from here, that means if you start from secant, you have to go through right hand side. So if you start from right hand side, that means the arrow is shows to the left. That means you have to go through left hand side. That's it. Now let's see how does it work. Find derivative of secant theta. So here is secant theta. So the arrow shows to the right hand side. That means you have to go through right hand side. That means you have to take secant theta times tan theta. So the derivative of secant theta, the formula is secant theta tan theta. If you want to find derivative of tan theta, that is equal to, just observe this, where is the tan theta? Here is the tan theta. That is, the arrow is showing to the left. So you have to go through left. That means you have to take secant. That means secant theta times secant theta, which gives secant square theta. Derivative of tan theta is secant square theta. Now let's take derivative of cosecant theta. Where is the derivative of cosecant theta? Here is the derivative of cosecant theta. Arrow show to the right hand side. That means you have to go through right hand side. That means you have to take minus cosecant theta times cot theta. Minus cosecant theta times cot theta. Now let's go and find the derivative of cot theta. Where is the cot theta? Here is the cot theta, and the arrow showed to the left hand side. That means you have to take minus cosecant theta times cosecant theta. Minus cosecant theta times cosecant theta, which gives minus cosecant square theta. Like that, simply you can write derivatives of these 4 functions. Now let's start with the derivatives of inverse trigonometric functions. We have 6 inverse trigonometric functions. Those are sine inverse of x, cos inverse of x, tan inverse of x, cot inverse of x, secant inverse of x, cosec inverse of x. So we have 6 inverse trigonometric functions. Here we are following few steps. Step 1. Write all C functions on right hand side. So we have C functions. One is cos inverse, cot inverse, cosecant inverse. So write all C functions on the right hand side. So we are finding derivatives. So just write derivative also. It's cot inverse of x, and the last one is cosecant inverse of x. Now write co-functions of these inverse trigonometric functions on left hand side. D by dx of cos inverse of x, co-function is sine inverse of x. Cot inverse of x, the co-function is tan inverse of x. And the last one, cosecant inverse of x, the co-function is secant inverse of x. This is our first step. Then step 2. You know that all inverse trigonometric functions are in quotients. So we have to write 1 over something. Like that, write for all inverse trigonometric functions, just write 1 over something. Because we know that derivatives of all inverse trigonometric functions are in quotient form. Now, on the right hand side for these C functions, assign a negative sign. Just assign a negative sign. And the fourth step is, so the bottom functions. What are the bottom functions? See, derivative of secant inverse of x, derivative of cosecant inverse of x. These 2 functions, write model of x in the denominators. Go for the step 5. In step 5, you have to observe only these left hand side derivatives of inverse functions. In the top sine inverse of x, the first letter is S. That means S resembles subtraction and square root, isn't it? So S stands for subtraction and square root. Just write square root and subtraction. Just mention the negative sign, that is subtraction, and then square root. And here also observe the first letter, we have S. So S resembles subtraction, square root. So just write here also in the denominator writes square root and subtraction. Now observe the first letter of the tan inverse of x. We have T. It resembles cross sign. That means plus. So just write plus. Step 6. On these spots you just write either 1 or x power 2. Observe first two functions, that is sine inverse of x and tan inverse of x. And observe the bottom function, that is secant inverse of x. So this secant inverse of x is bit different because in the denominator we have modulus of x. That means this is a bit different than these two functions. That's why sine inverse of x and tan inverse of functions you just write as identical. First two are identical and bottom one is a bit different. So write 1 and x power 2 for these identical functions. Just write 1 and x power 2, and here also 1 and here x power 2, because these two are identical and the bottom one is bit different. So write in different way, that is first write x power 2 and then 1. That's it. Derivative of sine inverse of x is 1 over square root of 1 minus x square. Derivative of tan inverse of x is 1 over 1 plus x square. Derivative of secant inverse of x is 1 over modulus of x times square root of x square minus 1. The last step is just copy all these denominators as it is and write it here. That is square root of 1 minus x square, you just write here square root of 1 minus x square. And here denominator we have 1 plus x square, copy as it is. Here denominator we have modulus of x, square root of x square minus 1. Just copy as it is, square root of x square minus 1. That's it. This trick simplifies learning for students across grades 8 to 12. I hope you like this content. If you like this content, please subscribe to my channel and give your valuable comments in the comment section. Thank you for watching.